Good morning, children. So, in the last period, we learnt about these direction cosines. What are direction cosines? So, what are direction cosines? So, you have the x-axis, y-axis, and z-axis. This is x-axis, y-axis. It should be always in the right-handed system. Rotation should be in the right-handed system, right-hand thumb rule. So, it should be in the anti-clockwise direction. Anti-clockwise direction. Now, suppose you have a line like this, then for this line, we define the direction cosines like this. Draw a line parallel to it and passing through the origin. Consider the ray passing through the origin and parallel to it. So, this line will make some angle alpha with x-axis, positive direction of x-axis, and then beta with positive direction of y-axis, and then gamma with the positive direction of z-axis. Then we define cos alpha, cos beta, cos gamma as the direction cosines of that line L, M, N. We denote them by L, M, N. And then we also proved that minus L, minus M, minus N are also the direction cosines of the same line. So for a straight line, there are two sets of direction cosines. L, M, N is one set, another set is minus L, minus M, minus N. And then we also proved that L square plus M square plus N square is equal to 1. L square plus M square plus N square is equal to 1, where L, M, N are the direction cosines. Now suppose that there is a point in the plane and its coordinates are x, y, z. And then OP distance, O is the origin, OP distance is R. Then we have the direction cosines of OP as just x by R, y by R, and z by R. So the direction cosines of OP are this. These are L, M, N. Now the distance OP is R. Now suppose that you have 2 points P and Q, x1, y1, z1. There is a straight line. So there is a straight line and 2 points on the line are P and Q, x1, y1, z1, x2, y2, z2. And then PQ distance, you know the distance formula PQ as R, that is root of x2 minus x1 or x1 minus x2 whole square, x1 minus x2 whole square plus y1 minus y2 whole square plus z1 minus z2 whole square. So this is OP PQ distance. Then the direction cosines of the line PQ are L, M, N is equal to x2 minus x1 by R. Suppose I write x2 minus x1, here I should write y2 minus y1 and z2 minus z1. Or else I can write x1 minus x2 by R. Then here also I should write y1 minus y2 by R and then z1 minus z2 by R. This is what we have learned in the last period. Now we'll do the applications of it. We'll do problems based on this. Okay. Now, see, the first we'll do the fourth problem. A ray makes angles pi by 3 with x-axis, positive direction of OX and OY respectively. Find the angle made by it with OZ. That means we must find gamma. So, in the solution, what are given? Given in our notation, alpha is pi by 3 and then beta is pi by 3. Gamma is gamma only. So now what is given? We are given this thing. We should find gamma. What is gamma? So we know that L square plus M square plus N square is equal to 1. What is L square? L square is cos square alpha. M is cos beta. So cos square beta. N is cos gamma. So cos square gamma is equal to 1. What is cos alpha? Pi by 3. So cos square pi by 3 plus cos square pi by 3 plus cos square gamma is equal to 1. Cos 60 degrees. Cos 60 is sin 30, that is half. So 1 by 2 whole square plus 1 by 2 whole square plus cos square gamma is equal to 1. So this is 1 by 4 plus 1 by 4. So that means 1 by 4 plus 1 by 4 plus cos square gamma is equal to 1. So what is cos square gamma? Cos square gamma is equal to 1 minus 1 plus 1, 2 by 4. So 2 by 4 means 1 by 2. So 1 minus 1 by 2 is 1 by 2. So it is 1 by 2. So that means cos gamma is equal to plus or minus root of 1 by 2. 1 by 2. So that is 1 by root 2. So it is plus or minus 1 by root 2. Now cos gamma is 1 by root 2. When it is plus 1 by root 2, you can write as cos 45 degrees. And when it is minus 1 by root 2, you can write it as cos of 135 degrees. That is 3 pi by 4. So for plus value, the gamma value is 3 pi by 4, and for minus 1 by root 2, gamma value is cos gamma is equal to minus 1 by root 2. Then it is 3 pi by 4. So you will write therefore gamma is equal to gamma is equal to pi by 4 or 3 pi by 4. So the angle made by the line ray. So you will write therefore the angle made by the ray, with OZ. The angle made by the ray with OZ is pi by 4 or 3 pi by 4. Pi by 4 or 3 pi by 4. So like this we do the problem. So here you are applying the property of L square plus M square plus N square is equal to 1. Okay. Now next problem is, so all these are actually example problems. All these 4 problems and yesterday's problems, they are all example problems, and they are important also. So the DCs of a line are this, find C. So in the solution we'll write the DCs of a line. The DCs of a line are L, M, N. In our notation it is element is equal to 1 by C, 1 by C and 1 by C. So we have the property that L square plus M square plus N square is equal to 1. So when you equate the corresponding coordinates, L is 1 by C. So 1 by C whole square plus 1 by C whole square plus again 1 by C whole square is equal to 1. Here because this implies L is 1 by C, M is also 1 by C, N is also 1 by C. So that means it is 1 by C square plus 1 by C square plus 1 by C square. That means 3 by C square is equal to 1. So when you cross multiply, 3 is equal to C square. So C square is equal to 3 implies C is equal to plus or minus root 3. So this is your answer. So like this we do the problem. So in these 2 problems, you are applying the property of L square plus M square plus N square is equal to 1. Even in second problem, we use the same property. So what is given here? The DCs of a line. Find the DCs of a line that makes equal angles with the coordinate axis. So in the solution, suppose that let the DCs of a line let the DCs of the line be L, M, N. Then what is given? It makes L. Okay, so let alpha, beta, gamma be the angles. Be the angles made by the line with OX, OY and OZ. With OX, OY and OZ. Then what is given? You are given that alpha is equal to beta is equal to gamma. So that means our L is cos alpha, M is also cos alpha, cos beta, which is seen as cos alpha because beta is equal to alpha, and then N is cos gamma. That because gamma is also equal to alpha, it is cos alpha. We have L square plus M square plus N square is equal to 1. So L square plus M square plus N square is equal to 1. L square is cos square alpha plus cos square alpha. L square is cos square alpha. M square is also same. So that means cos square alpha plus cos square alpha plus cos square alpha is equal to 1. So that means 3 cos square alpha is equal to 1. So that means cos square alpha is equal to 1 by 3. So cos alpha is 1 plus or minus 1 by root 3 plus or minus 1 by root 3. So when you bring 3 to this side, you will get like this. Cos alpha is plus or minus 1 by root 3. So now the direction cosines are So therefore the direction cosines, the DCs of the line are LMN. So LMN values, when you substitute, cos alpha is L. So it is plus or minus 1. This is L. Cos alpha is plus or minus 1. This is L and it is also equal to M, N and LMN. Both, all the three are equal. So we'll write plus or minus 1 by root 3 plus, again M is also plus or minus 1 by root 3. N is also plus or minus 1 by root 3. So actually there are 8 sets of values. Once you take all positive, 1 positive, 2 negative, 1 negative, 2 positive, like that, there are 8 sets of values. So here we can write like this. So there are 8 such directions. Which reduce to 4 lines. So there are directions wise, when you take, it is 8 possibilities will be there, and then they are the direction cosines of 4 lines. Okay, now the first problem is direct problem. You can just try. I'll do for one or first 2 I'll do. You can do the third one. Okay, so P, Q are 2 points. Find the direction cosines of OP. So you are given the P point as 2, 3, minus 6. Q point as 3, minus 4, 5. And then origin O is 0, 0, 0. Now first bit, we'll find the direction cosines. First, we must find the DCs of OP. Okay, I'll write DCs of OP. Okay. So to find the DCs of OP, we'll find R. R is what? Distance OP. OP distance. Root of O and P distance. So 2 minus 0 whole square plus 3 minus 0 whole square plus minus 6 minus 0 whole square. So like this, when you do, it is 4 plus 9 plus 36, 49, 7. So OP distance is 7. OP distance is 7. So now we'll write DCs of OP are X by R. P point is X, Y, Z. So 2 by 7 X by R. 2 by 7. Yes, 2 by 7 and then 3 by 7 and then minus 6 by 7. This is one answer. Now second one, to find the DCs of QO. QO is again same. We will write R. R is distance QO. So in the same manner, you find out the distance Q and O origin. So it is root of 9 plus 16 plus 25. 25, 35, 40, 45. 25, 35, 45. Yes, it is root 50. No, root 50. Yes. So now the direction cosines of QO. One is origin, no? So you can just write the coordinates. That is 3 by root 50. If it is OQ, it is 3 by root 50 and all. Because it is QO, it should be minus of. Because it is QO, it is minus of, 3 by root 50. He has not given OP. For OP, it is direct. For it is QO, it is the other set of direction cosines you have to write. 3 and then minus 4 by root 50 and then 5 by root 50. So that means minus 3 by root 50 plus 4 by root 50 and like that. So minus 3 by root 50, then 4 by root 50 and then minus 5 by root 50 like this. Next is the direction cosines of PQ. Third bit. the direction cosines of PQ. So here it is x2 minus x1 like that. So P is, we will find PQ distance. PQ distance is root of x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square. So it is root of 1 plus 7, 49, 11, 121, 49, 50, 171. So this is root of 171. So now we'll write the direction cosines of PQ as, so therefore the DCs of PQ are x2 minus x1. This is R. This is your R. So x2 minus x1 by R. Write the formula y2 minus y1 by R and then z2 minus z1 by R. Where P is x1, y1, z1, P is x1, y1, z1 and Q is x2, y2, z2. x2, y2, z2. Only for this it is like this. P and Q. So it is x2 minus x1 means 3 minus 2, 1. So 1 by root 171, y2 minus y1 minus 7 by root 171 and then 11 by root 171. So like this we do the problems. Finding the direction cosines. Okay, now you understood how to find the direction cosines. Now we'll do the exercise problems. Exercise problems. First section, second problem. Yes, first section, second problem. This is again very important for 2 marks. If a line makes angles alpha, beta, gamma with the positive direction of x-axis, with the positive directions of x, y, z axis respectively, then what is the value of sine square alpha plus sine square beta plus sine square gamma? So we know that alpha, beta, gamma. So we know that. So the line makes alpha, beta, gamma. The line makes alpha, beta, gamma with the positive directions of coordinate axis. With the positive directions of coordinate axis implies what are the direction cosines of that line? Implies the DCs of the line are L, M, N. So what are L, M, N? L is cos alpha, M is cos beta, N is cos gamma. This is by definition. So we know that property. What is the property? We know that L square plus M square plus N square is equal to 1. So we'll substitute cos square alpha plus cos square beta plus cos square gamma is equal to 1. So what is, we'll convert it to sine. 1 minus sine square alpha plus 1 minus sine square beta plus 1 minus sine square gamma is equal to 1. So now take sine square alpha, so on all to that side, 1 will get cancelled. This side 1 will get cancelled. So 1 plus 1 is equal to sine square alpha plus sine square beta plus sine square gamma. So that means sine square alpha plus sine square beta plus sine square gamma is equal to 2. So the value is 2. That is the answer. Okay, next problem. Okay, second section, first problem. First section, fourth problem you can take as homework. Here given 2 points. So first section, homework. You can take these problems. First section, fourth problem. He has given 2 points. Just find the direction cosines. So we solve similar problems. We can try. Next, second section, first problem. Find the DCs of the sides of the triangle. Find the DCs of the sides of the triangle. Sides of the triangle whose vertices are 3, 5, minus 4, and then minus 1, 1, 2, and minus 5, minus 5, minus 2. So these are the vertices. So we'll take them as A, B, C. So let A is equal to 3, 5, minus 4. B is equal to minus 1, 1, 2. And then C is equal to minus 5, minus 5, minus 2. Be the vertices of triangle ABC. So these are the vertices of triangle ABC. Now you must find the direction cosines of the sides. One side I will find out, remaining sides you can try. So first part, to find the DCs of the side, to find the DCs of the side AB. Side AB. So you have the triangle like this. ABC is the triangle. You are finding the direction cosines of this side. So to find the DCs of that side, you must find the distance AB. So the distance AB is R. So what is the distance AB? X2 minus x1 whole square. It is minus 1 minus 3 whole square. Plus y2 minus y1 whole square. So 1 minus 5 whole square. Plus 2 plus 4 whole square. 2 plus 4 whole square. So how much is it? Root of 3 plus 4, 16. Again 16, 36. 68. So it is root 68. Yes. So now we can write the direction cosines DCs of the side AB are what is the formula? X2 minus x1 by R, and then y2 minus y1 by R, and then z2 minus z1 by R. You can take plus or minus outside. Both you can take. So it is plus or minus. What is x2 minus x1? This minus this. So this is x1, y1, z1. This is x2, y2, z2. Because we are taking AB side. So minus 1, minus 3, minus 4 by R. R is root 68. Then y2 minus y1. 1 minus 5. 1 minus 5. These values only. 1 minus 5. Minus 4 by root 68. And then this 2 minus of minus 4. 2 plus 4. That means 6. 6 by root 68. So like this we find the direction cosines of the side AB. You take positive values. One set of values is enough, so we'll take positive values. Okay, DCs of the side AB. Now in the same way you find the DCs of the side, second part of it will be to find the DCs of the side BC. So you do in the same manner. That means now your points are B and C. So this becomes x1, y1, z1 and this becomes x2, y2, z2. So just to simplify, so you will get the answers like this. I'll just give you the answers. So the direction cosines, DCs of BC, side BC. DCs of the side BC are minus 4 by root 68, minus 6 by root 68, and then minus 4 by root 68. And then next is direction cosines of side CA or AC. One set you write. Okay, minus 4 by root 42, minus 5 by root 42, and then 1 by root 42. So like this, you will find the direction cosines of the sides of a triangle. Okay, next the last problem in this direction cosines is Okay. So still we have 5 minutes. Fourth problem you can take as homework. Okay, next is show that the lines. Second problem, show that the line PQ and RS, the lines PQ and RS are parallel where P is equal to 2, 3, 4 and then Q is equal to 4, 7, 8 and then R is equal to -1, -2, 1 and then S is equal to 1, 2, 5. So these are the points given. So in the solution, when are two lines parallel? Suppose you have x-axis, y-axis and z-axis. Suppose two lines are parallel. When you draw a line parallel to it and passing through origin, it will be same. They coincide. These two lines are parallel. The line parallel to it passing through origin will be same for both the lines. So that means the direction cosines of this line should be same as the direction cosines of both the parallel lines. The direction cosines of parallel lines are equal here. So we'll just find so you will write P point, Q point, and then R point and then S point given. You write all the points. R is equal to and then S is equal to 1, 2, 5 like this and then -1, -2, 1 and this is 4, 7, 8. This is 2, 3 and 4. Okay, now we'll find we'll find the direction cosines of this line PQ. To find the DCs of PQ. DCs of line PQ. For that, we need the length of PQ. So, what is the distance PQ? PQ distance formula. Root of x2 minus x1 whole square. 4 minus 2. 4 minus 2 whole square plus 7 minus 3 whole square plus 8 minus 4 whole square. So, what is it? 4 minus 2 means 2. 4, 16, 16, 36. That is 6. So, what are the direction cosines? So, the DCs of PQ are, the formula is x2 minus x1 by r. So, this is your r now. And then y2 minus y1 by r and then z2 minus z1 by r. So, you just simplify it is 4 minus 2, 2 by 6 and then 7. So, 4 by 6 and then again 4 by 6. So, that is equal to 1 by 3 and then 2 by 3 and then 2 by 3. So, these are the next step. We'll find the direction cosines to find the DCs of, direction cosines of the line. So, DCs of line PQ. RS. Next is to find the direction cosines of the line RS. So, same way if you do, you can write all these steps. We'll find the distance RS. So, distance RS is same formula 1 plus 1, 2, 4. And then 2 plus 2, 4, 16. And then 5 minus 1, 4, 16. So, here also it is 6. Okay, now this is distance RS. Now, we'll find the direction cosines of the line. RS. R. Same formula x2 minus x1 by r like that. So, 1 plus 1, 2, 2 by 6 and then 2 plus 2, 4, 4 by 6 and then again 5 minus 1, 4, 4 by 6 like this. So, there are again 1 by 3, 2 by 3 and 2 by 3. So, in the same manner, you find the direction cosines of RS also. Now, we'll conclude. So, the conclusion is we found the direction cosines of the line PQ and the direction cosines of the line RS and we found that both of them are equal. So, we'll conclude like this. So this is like third part of it. Since the direction cosines of the line PQ is equal to since the direction cosines of the line PQ are equal to the direction cosines of the line RS, the lines PQ and RS are parallel. The lines PQ and RS are parallel. So like this we conclude. Hence it is proved. So in this exercise still two problems are there that we'll do in direction cosines, direction ratios part. In B exercise also you have similar problems. So all the problems we'll do at one place. So with this we completed the first exercise. Now in the next period we'll learn about the direction ratio.